The next skill you need to be able to have is to identify like terms. Like terms are anything that have the same variables and exponents. And the reason we care is because you can group them together. So for example, if you look at this one, we have a 2z to the 4 and another z to the 4. They are like terms. So I have 2z to the 4s and I have another 1z to the 4. Then I have a 3x to the 4 and a minus 9x to the 4. And when you have like terms, it's like gathering bunnies. This is like I have 2 bunnies and another 1 bunny. So altogether I have 3 bunnies, or 3z to the 4. So nothing changes with the z to the 4. This is not exponent laws. This is different. When you're gathering like terms or combining like terms, all you can do is add the coefficients. You're saying I have this many of this, and the this never changes. So here I have 3x to the 4s, and I'm taking away 9x to the 4s, so I have negative 6x to the 4s. And that's the only thing I see people mess up, is that all of a sudden when they gather like terms, they want to change the exponent. You only change when you're multiplying, not when you're adding. Adding and subtracting just groups things together. All right, let's look at the next one. For this one, I have a 3t and I'm taking away a 4t. So I have negative 1t, and I don't need to write the 1. And then I have 4r's and I'm taking away 8r's. So I have minus 4 r's. Now, when you're doing these, you know how we were writing them in descending orders of power? That really works well when you have one variable. When you have two variables, it doesn't really matter. I mean, looking at this one, alphabetically, I should have put it in the other order. Same thing with this one. Maybe I should have written this as negative 4r minus t. I won't take marks off regardless. It doesn't matter. The order of adding never matters. So both of these are fine answers to this question. All right, what about this last one? Let's try to do this one in descending order. So this one would have a degree of 5. So we have x cubed z squared. Here's another x cubed z squared. So I have negative 3 plus 12 would give me 9 x cubed z squareds. Then I have this guy, which has 8 x squared z's, and there's no partner for him. And then I have plus 5x squared. So the only like terms were these guys here. Everybody else didn't have a partner. All right, now that we know how to combine like terms, you can add and subtract polynomials, because that's all we're doing here. So when you look at this expression, we're taking negative 5p cubed plus 6p squared, and we're adding to it 8p cubes and minus 12p squareds. So because it's adding, nothing's going to happen with the signs. So I could say I have negative 5p cubes, and I'm adding 8p cubes. I have 6p squareds, and I'm taking away 12p squareds. That's going to leave me with 3p cubes and minus 6p squareds. This is called, I don't know if it really has a name, but like linear adding maybe, because it's all in a line. But there is this other way of adding where you get to stack them on top of each other. And when we do start multiplying polynomials together, I do find stacking them on top really nice, because then when you're adding, you could put the like terms on top of each other. So here I have negative 6r to the 5 and a plus 8r to the 5. And since they're stacked, I can see that they're like terms. Same thing here. I have 2r cubed, so I'm taking away 2r cubed, so that term is gone. And then I have negative r squared, and I'm adding 5r squared, so I'd have plus 4r squareds. So it's kind of nice, like even this one I could have taken it and stacked it, and then it's nice to see the like terms, especially if you end up with like 8 terms that you're adding together. It's hard to see all the like terms in a line, whereas if you stack them, they're a lot easier to see. So it's just a skill, just looking at it a different way. Same thing with subtraction. So if I go to look at this one, the first bracket's not going to change. I have p to the 4 plus p cubed plus 5. Now I'm going to distribute this minus sign through the second bracket. You could keep writing it linearly, or I could stack it, right? If you like how that last one was done, you could then go, this is minus 3p to the 4, whoops, 4, minus 5p cubed minus 2. And instead of writing it as a big long line, you can stack it. So it's just showing you that there's other ways of displaying information other than the old school, hey, write it in a line like you've always maybe done. So if you don't like this, feel free to just put minus 3p to the 4 minus 5p cubed minus 2 on the end. That's fine. And so I like them stacked. I find it easier to keep track of. So 1 minus 3 is negative 2. 1 minus 5 is negative 4 p cubes. And then 5 minus 2 is 3. And because I changed the signs, then I was adding these two rows, right? Because I distributed my negative, which meant I was going to add. When you get to a question like this one, this is asking you to subtract, but it's written in this stacked way. You have two choices. You can go through and go 2 minus 4, negative 3 minus 6, negative 2 minus 5, 5 minus 8, and you can just kind of use that sign as you go through. I find lots of people mess that up though. So if you were going to do this one, what I would do is rewrite it. 2k cubed minus 3k squared minus 2k plus 5, and I'm going to take away 4k cubed. I'm going to take away 6k squared. I'm going to add 5k, and I'm going to minus 8. So I distributed that negative sign just like I did here, and I rewrote it stacked. And again, you could have done it as a big long line if you wanted to. This is going to give me negative 2k cubed minus 9k squared, because now I'm adding. Because I changed the signs, I get to add. And then plus 3k and minus 3. And that would be my final answer.